Today my class is on geostationary satellite. We have to calculate the height of this satellite. This is very important for not only board exam but also in different competitive exam. So I give a complete idea about the calculation of geostationary satellite. I think this class is helpful to all students. So first we write down some points. So let a geostationary satellite of mass m is moving. A geostationary satellite of mass m is moving in a circular orbit of radius r around the earth of radius r and mass m. So we first consider a geostationary satellite of mass m is moving in a circular orbit of radius r around the earth of radius capital R and mass capital M. So let orbital velocity of the satellite is v. The force of attraction between the geostationary satellite and the earth, that is F equal to g by r square. Here r equal to r plus h. The centripetal force for moving circular orbit is Fc equal to mv square by r. So required centripetal force, that is Fc equal to mv square by r. Now that is Fc equal to F. So mv square by r equal to gmm by r square. So we can get that is v equal to, that is gm by r. That is time period t equal to, we can write 2 pi r by v. So t equal to 2 pi r v, that is root over gm by r. t equal to, that is t equal to, we can write t equal to, we can write that is 2 pi root over gm, that is r to the power 3 by 2, squaring on both sides, squaring on both sides, that is t square equal to, that is gm, that is r cube. So we can write t square equal to 4 pi square by gm into r cube. So we can write that is r cube equal to t square into gm by 4 pi square. So again we know that is g equal to gm by, this is r square, r square. So gm equal to, you can write gr square. So r cube equal to, we get that is the t square gr square, এটা হলো 4 pi square. So r equal to, that is t square gr square 4 pi square to the power 1/3. So this is the value of r. So here that is t equal to, we can write that is t equal to 24 hours, that is 24 into 3600, that is 86400 second. So r equal to, we can write 6400, so into 10 to the power 3 meter. This is in kimi, we transfer meter. So g equal to, you can write 9.8 meter per second square. So r equal to, that is t square, that is g, that is 9.8, r, that is this is square, and next that is 4 pi square, this is whole to the power, we can write that is 1/3, whole to the power 1/3. So this is the value of r, that is 42400 kimi. So r equal to, we can write, so r equal to 42400 kimi. So this is the radius of, this is the radius of parking orbit, So this is, that is r plus h, r that is given. So h equal to, we get the value that is 36,000 kimi. So hence the height of geostationary satellite from the Earth's surface, that is 36,000 kimi. This is the value of h. Again, that is orbital velocity, that is orbital velocity of geostationary satellite, that is v equal to, we can write that is gm by r, that is gr square by r. So we get the value, that is putting the value, that is v equal to r, that is g by r. So v equal to, we can write that is 6.4 into 10 to the power 6, that is g, that is 9.8, r, that is this is the kimi, it transforms into meter. So that is v equal to, we can write 3.076, this is kimi per second. So today we have learned the height of the geostationary satellite and also orbital velocity. These two topics are very important for different sections. I think my class is very much helpful for all students. Please watch all the videos and subscribe my channel. Thank you all my dear students. Thank you.